Good morning, friends. Welcome to goonlinetrainings.com. So, from today, we're going to understand some more important concepts called data warehousing concepts. So, let us have a small intro on what is a data warehouse and how we can understand a data warehouse and how to design a data warehouse. All of them we have to be clear with. Okay. So already you know that how the BI application is developed. So you have OLTP, then you have for data warehousing and lot of things we have it there. So we have different OLTP applications. Using this, we may use ETL and we dump the data. We're going to clean the data in staging. From the staging, the data will be going to the data warehousing applications. Okay. So whenever it goes to data warehousing applications, so the data warehouse is going to have last 10 years of historical data, and this data will be dumped onto a OLAP server or data warehousing server. Okay, so now the first question is we have to be asking who's the father of data warehouse and who's the inventor of data warehouse? Dr. William H. Inman and Ralph Kimball. These two are the gurus for the data warehousing concept. And many people who's referring data warehousing today, they have to use either William H. Inman data warehousing approach or they may use Kimball approach. So data warehousing is having two approaches. One is Inman, the second one is Kimball. Let us understand one by one. So the first question is, so we were doing a lot of ETL, we're cleaning the data here, and again we are using a lot of ETL with the help of full loading, incremental loading. We have to keep the data in the data warehouse. The first question, what is the data warehouse? Okay, if you ask me what is a data warehouse, so according to Inman sir, the data warehouse is subject oriented. Okay, so the data warehouse is subject oriented and the data warehouse is integrated and non-volatile and time variance data. So what is the meaning of that? For example, I have some data here. Let us talk about I have a bank. Okay, I have a bank. Okay, so let us say we have ICICI Bank or Citibank, something like this. So these people will have a OLTP applications. And from the OLTP application, the data will go to stage. From the data, it is going to go to data warehousing applications, right? We're talking about OLTP. Now, whenever you go to OLTP applications, the data is stored here. But the question is that how the data warehouse is designed. The first question is what is a data warehouse? Now, you think about ICICI Bank, where you have a lot of data is being generated. For example, ICICI Bank may deal with a lot of loans data, may deals with a lot of credit card data, may deals with a lot of savings banks data, may deals with a lot of mutual funds data or fixed deposits data, mutual funds, fixed deposits, like that. You have plenty of different variety of data one company is going to generate. Clear about it? Okay, so they may have insurance, they may have a share market data, a lot of data a company can hold. For example, you take Amazon.com, they have a lot of data, customer data, product data, sales data, marketing data, HR data, lot of different data is being generated in the OLTP. So OLTP is not meant for it to store only one kind of a data or one type of a data. We'll be having different type of the data we're talking about. So put together the OLTP Amazon database. So when you take Amazon database, you may have HR data, sales data, marketing data, lot of data you will be able to keeping it here. So for the same database, you're going to create Amazon stage database. Now here all the data from the Amazon is going to be dumped, and this server would be a staging server. And from here you have to create a Amazon DW database. Okay, so what is a data warehouse? Data warehouse is also one more database only, but only thing is that which is going to accumulate a lot of data. Last 10, 20 years of data is going to be accumulated in the data warehouse, and last 1 year data, last 6 months data, you will be able to store it here. Okay. Now the first question is that what kind of a data either a bank or Amazon is going to store. So when we're talking about a bank, so you have this kind of a data you have, right? Now what a data warehouse is, data warehouse is not going to take all the data, and we're not going to dump everything here. So data warehouse will have lot of subsets of data. What does it mean by that? So you may have loan data will get separated. You have say credit card data will get separated. You have mutual funds data will get separated. So like that, a data warehouse will have different subjects data put together. Clear? And this subject is called as a data mart. Okay. So we're talking about a data warehouse. If you think this is a folder, you think like this. Data warehouse is a folder. Inside the folder, you have a lot of subfolders. For example, I have a folder called songs folder. Okay. So inside songs, you have a subfolder called say English songs, one more subfolder called Hindi songs, one more subfolder called Telugu songs. So you can think as a songs as a data warehouse. Each subfolder you could be calling as a data mart. So what is that Hindi songs? So which is subject oriented English songs. So we have categorized the data based on the language. Clear? So you can have any kind of a classification or the categorization. That is what is called as a data mart. Okay. So data mart means a subfolder in our example. So data warehouse means a main folder in our example. Okay. So that is what is the first point you have to understand. So data mart means subject oriented. So no company is going to take all the data as it is. They are not going to dump all the data in the data warehouse. They are going to create a lot of data marts. Okay. So then each data mart, you can also call it as a small data warehouse. So subfolder is also a folder. Folder is also folder. What is the difference? Subfolder means size wise is very small. For example, I may have some 2 terabytes of loan data. I may have a 5 terabytes of say credit card data, but all of them are part of enterprise data warehouse. So data warehouse means collection of all these subfolders. Clear? If somebody says that, array, we don't have data warehouse here, we have a small data mart. But what is a data mart? Data mart is nothing but a data warehouse only, but which is the only one subject data and little data you're going to store. That is what is the point you need to understand. Now, how the data is classified, categorized. Now we're talking about different subjects. So subject could be based on the English language, Telugu, English songs, Telugu songs like that. That is language oriented specification or categorization. Or you may also say 1980s songs, 1990s songs, 2000 songs. This category is called as a time wise categorization. That is also fine. So somebody wanted to analyze 1990s data across all domains or 1990s data. That is one kind of a classification. 1990 songs, 2000 songs like that. Or you may have a categorization like music director wise. For example, I wanted to have Ilayaraja songs or Michael Jackson songs like that. You can have artist wise classification. Are you getting the point? The subject means it could be a time wise subject, or it could be a actor wise or actor wise subject, or singer wise or music director wise. You should be able to do some kind of subfolders. Are you clear? So each subfolder is called as a data mart. So data mart is a subset of a data warehouse which is going to focus on different subjects. Now the point here is that you may have a lot many branches. So loans data from branch BR1, branch BR2, from various places it's going to come, which is going to integrate it here. So in our example, if you see, these are, you can say loan is a one more data mart. Insurance is one more data mart. So credit card is one more data mart. So like that. So data warehouse is collection of data marts. That is what is the point here. Clear? Now, all of them are going to have historical data, but the only thing is that you should be able to point that this data is coming from various sources. So you may get loans data from here, dump it. You may get loans data from here, you have to dump it. So you get loans data from here, you dump it. You get insurance data from here. So you need to integrate and combine it here. That is what is called integrated. So many sources are producing loans data. Many sources are producing credit card data, something like this. That is the second point. The third point would be non-volatile. So that means what? Nobody should be able to modify the data once you load the data to the data warehousing applications. That is non-volatile. Read only, historical kind of a data. Now, the fourth is a time variant data. Different time data is going to be storing because time is one big, factor in the data warehousing to perform analysis on the time data. Clear? So when you have these four things, you should be able to call a database is called as a data warehousing database. Clear? Now, what is the
Just
data
one
mart?
question.
Yeah, please ask.
Yeah, non-volatile in the sense like data will not change, isn't it?
Non-volatile in the sense it is not 100% change. More, it is not going to change. Something like that.
Yeah, because each record when we get from the source is automatically saved as a historical data.
Correct.
Okay.
Yeah. Okay. So historical data, for example, history also sometimes you need to change. So, for example, let us take Amazon is there. Amazon address from OLTP has gone to data warehouse. So Amazon has changed their office, corporate office from Redmond to some Chicago. But the OLTP will change the address, but in the OLAP also you have to change the address, right? So even the OLAP is read-only database, but the address has been changed. If you wanted to take a report from the OLAP, and in that it is showing for each and everything the old address it was showing, but OLAP also we have to change. Sometimes we have to modify the data warehouse data, but most of the time we don't change. So we can treat it as a historical, but sometimes we have to change. Am I clear?
Yes, sir.
Yeah. Now, what is the data mart? Data mart is a subject-oriented data. Data warehouse is a collection of data marts, and the data warehouse is superset of a data mart. Superset means it is a bigger. Okay, na? So data warehouse is bigger than the data marts. Data mart is also another small database only. Clear? Now you think every month you are getting some 50 GB of data. You think like that, or every month you're getting some 100 GB of data. So if these applications are storing 1 year data, approximately 1 TB of data these applications are storing, right? Every month if they get 100 GB of data, 100 GB means we're talking about say 50 to 100 millions of data. So 100 GB is not a small amount of data, right? 100 to 200 millions of data these people are getting every 100 GB every month. So 1 year data approximately 1 TB or 1200 GB of data. Now, if you take every month 100 GB of data, and if you take this SSS package and clean the data and dump it here, so 1 year, 1 TB, lost 10 years of data in your data warehouse could be 10 terabytes of data or 20 terabytes of data for last 15 years. You can say like that. So people may ask you, what is the size of the data you have in the OLTP application? Or every month, what is the size of the data your applications are getting put together? You can say 100 GB of data. So 100 GB means 1 year, you should be able to get 1.2 terabytes of data. So last 10 years data is in your data warehouse would be 10 or 12 terabytes of data, which is a huge amount of data for the data warehouse to store. And on that, you should be able to load and do a lot of analysis on that. Okay. So something like that, you can also say your this one. So what is a data warehouse means? Data warehouse means it's a centralized large database which stores integrated, summarized, and historical data for analysis and decision making purpose. So why the data warehouse is built? So nobody is going to keep the historical data. Otherwise, if they don't need it, people would have, deleting the data after taking a backups, right? So they never, if they're never going back to the old data for analysis, nobody would be using this as a data warehouse, and they'll be taking a backup of the OLTP data. They delete the data from OLTP, that's gone. But now we're talking about OLAP applications. OLAP means the data should not be in the backups. The data is available in a server with online. So OLAP means that, and historical data, where you do lot of reporting, lot of analytics, a lot of data mining things. You're going to do it. So data warehouse is very, very pretty much important now. Okay, so from 1970s onwards we started using OLTP, but after 20 years, 1970s, then you have 1990s, where the data warehouse is the concept got introduced. Okay, after 20 years, so people are talking about data warehousing during 1990s time. So after 1990s, now people in 2005 and 6, people are talking about unlimited data. Now we have, GBs of data, now terabytes of data. Then now people have talking about big data. So from OLAP, people are moving. OLAP is only for the terabytes of data. Now people are moving to big data. Big data means unlimited data, where Hadoop is going to be, using big data concepts, right? So data warehouse 1990s concept. 2000 and 2005, this time Google has, Google and Apache people have invented a new concept called big data. Big data is a unlimited data. For unlimited data, storage is the problem. Okay, for that problem, they have invented a software called Hadoop. Okay, so what is a big data? If somebody asks, you have to say problem for what? Storing. Problem for what? Processing. Clear? So big data is introduced in 2005 and 6 by different people in this world. Now, now we had also understood a important concept that is called OLTP and OLAP. So what is OLTP means? We discussed about transactional data, daily business data, which is getting, stored in, Amazon, and the data will get transformed to OLAP or data warehousing, right? So which is a design for analytical purpose, reporting purpose. Data modifications are frequent and data modifications are not frequent. It is not 100% historical data, but sometimes we have to modify it. Has normalized tables and you have denormalized tables. So as normalization means, normalization improves, writing capability. So because of that reason, so many people are going to use normalization in the OLTP applications. But in the when you have large amount of data in the, data warehouses, once in a while you dump the data, then many times you're going to read the data. So OLAP application is for reading, OLTP application is for writing. So normalization will improve writing capability by splitting the data into many tables, and denormalization will improve the reading capability. So it takes two tables and it's going to combine the data. So combining the tables into one is a denormalization, and one table you split into two or three. This is what is called normalization in brief. So later we'll see some more points about these two concepts later. But OLTP will have, more normalized tables, and data warehouse will have more denormalized tables, so less tables. That is the point here. And more users are going to be connected to the OLTP. For example, when you open icsabank.com, so we go to ATM and we withdraw cash, or you go to bank and deposit cash. Okay, all these ICICI Bank applications, Amazon applications, or Flipkart.com, or Citibank.com, or whatever any BigBazaar.com in India. All these things are completely OLTP applications. As an end user, you will not be able to see any OLAP applications, right? Because OLAP is not meant for the end users. OLAP is meant for the business people to do some kind of analysis. So people may ask you, have you seen any OLTP applications? Means whatever you had seen is OLTP, Paytm, bookmyshow.com, Flipkart, Amazon.com, whatever you think of in India or abroad. Okay, so many users are available, and read and write data, read only data, fresh data, and historical data. Fresh means, OLTP, some people may use 1 month data in OLTP, some people will keep only 1 week data, or some people may keep 1 year data, or some people may keep 6 months data. Depends upon the availability of the space in the OLTP. If the OLTP is 80% is full in every Sunday, then every Sunday and a Sunday they're going to dump the data. If OLTP is because 80% is full on every fourth month or sixth month, then once in a 6 months they may dump the data to the destination. Depends upon that. Or they wanted to have every month they wanted to see the reporting last week data. I wanted to have in my reports in the data warehouse. If I wanted to have last week data in my data warehouse, and definitely I have to dump the data. So the report demands that I wanted to have a last week data in my report. That report is being created in the data warehouse side. Okay. In the data warehouse, the customer is saying every week I should have a report, but the report has to be generated in the data warehouse. That means what it's clearly saying, every week you have to dump the data to the data warehouse, and on Monday you dump it on Sunday, and Monday you create a reports on that. So if the customer is telling like that, then definitely you need to dump the data, whether it's 1 GB of data or 10,000 rows or one row. You need to dump it on every Sunday. So weekly dumping is necessary so that we are going to get and create a reports on data warehouse and on the historical. So historical means we're talking about every weeks I have to create a report and send it like that. Clear? So depends upon the situation to situation. We'll be doing a lot of things and lot of customizations and lot of automations of our ETL process and everything. Okay. Now there are two approaches to build your data warehouse. One of the approaches given by Bill Inman. In this, data warehouse is created first, then the data marts are derived from it. Data marts have consistent data and which is subject oriented. It has robust against business changes. The cost of the product is very, very high. So, what is the point here? The point here is that we have to take first you take OLTP data. From OLTP data, you prepare ETL and you create one data warehouse. Okay, let me show you in the paint. It will be good for you. Now, this is my OLTP and this is my thing like this. Okay, so this is my OLTP application. I am performing a lot of data and dumping into data warehouse. From the data warehouse, you dump it, and later you create a data mart 1, data mart 2, and a data mart 3. Okay, so these are called data marts. Okay, now what are we talking about? This data mart is called loans. This data mart is called say mutual funds. This data mart is called fixed deposits like that. You create a data warehouse first, so you get all the data dump into one single folder. Then using that folder, you create lot of subfolders. You dump all English songs one side, you dump all Telugu songs other side. So like that, you get the data first, then you create subgroups. So this is what is called Inman's approach. Okay. So in March approach, so this is what is the enterprise data warehouse. Using this, you're going to create data mart. So 30% of the companies are using this approach, but remaining 70% of the companies they are using Kimball's approach. So bottom up approach, it's proposed by Ralph Kimball. Data marts are created first and then integrated, and the comprehensive data warehouse created using the data marts data. Okay. So as the data marts are created first, business solutions can be answered very quickly because here we're going to focus much more on. So you have OLTP, you have not the data warehouse. First, you have data marts are created like this. Okay. Now using this, you should be able to create a data warehouse. Okay. Now let me take this OLTP. The data will go like this. And from here, the data is going to go here. And let me write, this is OLTP database. And this is a data warehouse database, but this is loans data. This is mutual funds data. And this is fixed deposits data like this. So this is the things many people are following and many people are doing this. So this is more, Kimball approach, and this 70% of the companies are using. So people may ask you, what is the data warehousing approach you're following? So many people are create a this kind of an approach, and they're going to create a lot of data warehousing applications. Am I clear, guys? So this is what is the important point that we have to be worried about. Do you understand? So, what is a okay. So we had seen what is a data warehouse, and today let us talk about one more important concept that is called dimension modeling. Okay, so let us understand what is a dimension modeling and who has given the dimension modeling concept and why we have to use. So when the customer is giving you data, they're going to give you the data in the OLTP applications, right? Now the OLTP applications data we have to convert into data warehouse data, right? So we have to understand how to design a data warehouse and introduction to dimension modeling, and what is a fact table or what is a measure table, and what is a dimension hierarchy and types of dimensions. And let us also introduce what is a star schema, snowflake schema, all of them. So these are the data warehousing concepts only. Okay, so today's concept, what is that? We are talking about OLTP and OLAP. OLAP means I'm talking about data warehousing. So OLTP applications, when they create any ICICI Bank application, they have a ICICI Bank database. Okay, but how the database will be created? So to create a OLTP database, you have to use a concept called ERD modeling. So ERD modeling means entity relationship diagram. This modeling concept given by Dr. Peter Chen in 1970s. For example, I'm constructing a house. So definitely somebody has to design that, right? If somebody has to design, and what is that concept they're going to implement to design my house? And designing means completely paper and pen work. Remember that point. It is there is no coding, there is no technology, there is no nothing. So ERD modeling is completely paper and pen work. And if you want to create any OLTP applications, for that OLTP database if you wanted to create, so ERD modeling is used. Okay, now OLAP or data warehouse, if you want to create a data warehouse, you should also design the data warehouse, right? So the data warehouse designing is done by using a concept called dimension modeling. This dimension modeling is the concept, given by Dr. Kimball. So Kimball became so famous in the data warehouse because of dimension modeling and the bottom up approach. Clear? Now the first question is, what are the tables in OLTP and what are the tables in OLAP or the data warehousing applications? Okay, now let us talk about it. Now OLTP will contain two types of tables. What are they? OLTP contain master table and OLTP contains transactional tables. Okay, but a data warehouse contains dimension tables and fact tables. Okay, now what is a OLTP table and what is a master table, transactional table? Let us understand. Okay, now remember, whenever any company is going to give you the data, so they will give you OLTP database. From the OLTP database, we have to create a data warehouse database. Now, OLTP is also database. For example, we're talking about say Amazon database, right? Okay. I'm talking about this is my OLTP data and this is my Amazon DW data. This is my data warehouse database. And if you ask me, this is OLTP and this is my data warehouse DB. Clear? Now you're going to perform a lot of ETL operations that already we discussed. Incremental loading, this loading, that loading you're going to perform. But Amazon database, which is going to contain tables, because database means you're going to have tables, and here also you're going to have tables. But What are the tables this fellow is going to have? Let us understand. This fellow is going to have tables, and this fellow also going to have tables on. Okay, but this fellow will have two types of tables, and this fellow also will have two types of tables. Okay, now what is the type of the table we have it here? You have master table and you have transactional table. You have master table and you have transactional tables. Let us understand what is a master table and what is a transactional table. So here we have a table called dimension tables. Okay, and here we have a table called fact tables. Okay, so data warehouse naming convention is you have a dimension tables and you have a fact tables, and OLTP naming conventions are called as a master tables and transactional table. The question is that what is a master table and what is a transactional table? For example, Amazon is having a table. For example, Amazon, when you open, you will get a lot of products. There is a table called products table or product master table, people will say. And whenever you go to Amazon.com, you have to register, right? So you're the customer. So it may be having one more table called customer master. So people are going to give you a naming convention as product master because it's a master table, customer master, and it is a master table. And whenever you buy any product, okay, whenever you buy any product, so you're going to do a lot of sales, right? So the sales is calling as the sales table or orders table is called as a transactional table. So okay, but how come I'm able to tell you this is a master table, this is a transactional table? Let me give you few things. Okay, master table means, okay, master tables, I'm talking about say product table or product master table, where you have a product ID, product name, product price. Okay, and you may have some more things also. And customer table, so you say customer master, where you have customer ID, customer name, customer address, customer city, customer phone number, something like this. You have few things. So, and we're talking about transactional tables. Transactional table means I just now told you sales table. So, what are the things we have it here in the sales table? And what is the product? And who's the customer? And what is the date of sales? And what is the quantity he bought? What is the sales amount or amount he paid? Something like this. Now, how can we say this is a master table, it is a transaction table? Simple thing is that master tables will have primary keys, okay, and transactional tables will have foreign keys. This is a simple way. So here in this table, what is the primary key? The primary key is a primary key. PID is a primary key, and in this table, what is the primary key? In this table, customer ID is a primary key. But now, in this table, sales table is a foreign key, and here you will be able to have foreign keys. So, master tables always will have a primary keys, and a transactional table always will have a foreign keys. This is one distinction between what is a master table, what is a child table, or what is, sorry, transactional table. One more thing you need to understand. So this table will have more string data. For example, product ID, product name, product category, price, lot of them, customer name, address, city, more string data. But here you will have more numeric data. Are you getting my point? So, what is a transactional table? And you will have more and more customer number, date of sales, quantity, amount, more numerical data is being stored in this. Here, more string data is being stored. So, when somebody says that, when you have a more and more textual data, string data, that would be a master data, details data or master data. This is second concept. The third very important concept is master tables are going to have less data compared to transactional table are going to have large amount of data. So here we are going to have a small amount of data. Okay, here we are going to have large amount of data. Let us understand daily how many new products you may the Amazon people may insert. So they may insert some 10 or 20 new. So but daily how many people they're going to buy? The sales is 1 crore people or 1 million people are going to buy. So more and more data not in the here, because you have 1 lakh products already. But today when you open the Amazon site, you may delete the products, you may add some 20 extra products, but not 1 million products every day, right? But every customer, you have already 1 crore customers, but every day you will not get 1 crore customers, new customers. So you may get some 10% extra or some 5% people will disappear. But when you see in this table every 1 hour you will have a millions of rows getting inserted. So if you have, let us say this is 50 GB of table, okay? This is 50 GB of table you have space. Let us say this is some 40 GB of data you have, and this table itself will be having some 500 GB of data. Think like this. Okay. So whenever you're thinking about a master table and transactional table in the OLTP, which table is going to occupy more and more space, which table is busy and more, that table will be called as a transactional table. So these three you have to be clear. Where you have primary keys, where you have more string data, where you have small size data compared to these tables. So these tables are called master tables, and the naming conventions also people are going to give master like this. Okay, so master tables primary key will be foreign keys of the transactional tables. Will have more and more numerical data, and more large amount of data will be there. Clear? So in OLTP master tables, so these master tables from OLTP, okay, in the data warehouse, we will be calling them as a dimension tables. Are you getting? So now, what is the name of the dimension? So you have a product master. Okay, you have a product master. Sorry, let me give you like this. You have a product master, but the same product master will be called as a dim product. That is a naming convention. Okay, so this is going to have a primary keys and all. And we're talking about customer table here. Okay, we're talking about customer table here. The customer table will be called as a dim customer table here. So the naming convention is changed. Now we have a sales table here. The same table here will be calling as a fact sales. Clear? So data warehouse will have a tables called a dimension tables and fact tables. All master tables will be, so master tables or dimension tables means where you have a more string data, more primary keys, and all the primary keys of dimension tables will be part of the fact tables. Clear? And the fact tables or sales tables transactional table will be calling it as a fact table where you have foreign keys and you have numerical data. This is how the data warehouse is built from scratch. Am I clear? So you have to be worried about. So without the OLTP, you will not be able to derive or create a data warehouse, because data warehouse data has to come from OLTP only. But if you don't study the data warehouse properly, and you will not be able to, clearly create a data warehouse tables. But what are the data warehouses going to contain? Data warehouse is going to contain a dimension tables and factor tables, and the tables are going to be linked with the dimensions of the primary key is linked the fact tables foreign key, and the dimension tables are string data, Factor tables are going to occupy more and more numerical data, and the factor tables are big in size. Remember this point. Okay, so whenever you dump the data, more data, I just now told you, more data is always come from this table only. Okay, so more frequent jobs also, more on SSS package also will be running on this data only, not on this data. Clear? So this is what is the first point we need to understand. Okay, so whenever you dump the data from here, what are we going to do? We are going to delete all the data from source. So you will get 0 GB. So when you move the data from here to here, we are not going to delete the data. If you delete the data, Amazon site cannot show you the products. Amazon site cannot take the new customers and data. So this data should not be deleted from OLTP. So once you load the data, so only transactional data, because you need not display the data. How many products you bought last 5 years. The data need not be there in the amazon.com. So Amazon site will maintain last 1 month data, 1 year's data, or last 1 years of your products. So it is not going to keep last 10 years of the data. So always when the dump the data here, they may delete the data here. So if the OLTP is full, and when they delete 500 GB of data, now it is again free. Now again they're going to take the data. So but here they're not going to delete. So tomorrow they may add, say, some 1,000 rows extra. Okay, so here tomorrow they may add some 500 rows extra. So here the incremental loading is done. So because you're not going to delete anything, because you have some 5 million data plus you have 1,000 rows. So whenever you perform an incremental loading, dimension tables always will have an incremental loading, but incremental loading should not be given to the fact. Incremental loading means what? You have to use old data plus you are going to append something here, because when you delete the data, once you load it here, there is no new data here. So people are not going to append any data here. So factor tables or transactional tables will not be configured for the incremental loading. SCD, slowly changing dimension, or all of them are not used for the factor tables or the dimension transactional tables. Okay, so only for this tables only we have to implement incremental loading or this loading. That is also one more point. Again, tomorrow it is going
So
to
can you
grow.
repeat that point, the last point? Sorry.
So dimension tables will have incremental loading. The transactional tables will not have incremental loading. So whenever you're performing incremental loading, so master tables will have, these are called dimension table, right? So only incremental loading you need to configure it here, but not for these fellows. Okay, remember that point. So this
Okay, sir.
fellow, so will this fellow is not going to have any data here, GB. So here you should not. It is always full loading. Remember this, full loading, full load of SSS package. Okay, na? So
And
this
full
is
load in the sense like type 2 SCDs, historical.
historical data only, but you are not going to mm, perform any kind of a incremental loading. Clear?
Okay.
So here there is no SCD also. There is no SCD also. Simply take the data from this table and dump into this table. Clear? Are you getting my point or not? So fact table
Not
will not
really.
have historical data. You may have historical data for the dimensional tables.
Yeah.
Okay, na?
Yeah. Only the transactions will be loaded into the
That's it.
fact table.
Yeah. So no historical data, no, because everything is historical data only. But here you will not be able to, maintain any kind of a slowly changing dimensions, things like this. So that is the point I'm trying to tell you. Okay.
So transactional in fact table, you will not have any type 2 SCDs.
So SCD is not that all there.
Okay.
So only
So only
SCD.
for the dimensions only will come into the picture for
Correct.
SCDs.
For all SCDs, only pure dimension tables only, and lookup incremental loading. SCDs, everything for the dimension tables only. So transactional, there is no thinking of SCD. There is no thinking of lookup incremental, nothing.
Oh, okay.
Okay. So
Okay, sir.
this is what is called a dimensions and facts. Tomorrow I'm going to talk about. So what is the dimension modeling concept given by Kimball, sir. So this is a layman understanding of dimension table and fact table. And here we will be calling this as a dim product table. Okay. And here this will be what? This table will be dim customer table. Okay. And here we'll be calling as fact orders table or fact sales orders table or fact sales table. Am I clear? So this is the simplest way to understand a data warehouse and this. And so you need to create three packages, one package for the product table, one package for the customer table, and we should have incremental loading logic, SCD, and anything else, or SCD or lookup incremental loading. And the sales table should not have any kind of incremental loading. It is always full load. Okay, guys, any questions? Tomorrow, I'm going to talk about dimensional modeling. What the other way of telling the data warehouse design concept is this.